Hi and welcome to Chemipedia, chemistry classes for 11th and 12th standard. So in this video I am going to discuss about the IUPAC nomenclature of coordination compounds. That is, I am going to discuss about the various rules which are used for naming coordination compounds. So point number 1, while naming the coordination compounds, cation is named at first. The name of cation is given, but first anion next, which is followed by the name of the anion. This rule is similar to simple salts. This is similar to simple salts, whereas in case of while giving the name of simple salts like sodium NaCl, which is called as sodium chloride, here sodium is the cation, chloride is the anion. While giving the name of this simple salt, first we give the name of the cation followed by the name of the anion. Sodium cation, chloride anion. The same rule is followed for giving a name of complex salts also. Okay, cation is first name, which is to be followed by anion. Now let us see the example. So in the first example, so this is the cationic portion. The first portion is always cation, the next portion is anion. But here this is cationic portion, this is anionic portion. But while naming this complex, the K plus ion is first named, which is followed by the name of that square bracket portion FeCN6 4-. Similarly, the next complex, here this square bracket portion is cation. This is cationic part and this is anionic part. While giving name of this complex, first square bracket portion is named, followed by the Cl, that is anion, isn't it? Right. This portion is named at first, followed by the anion Cl-. Look at the third example. Here the first square bracket portion cationic portion. This is cationic part. And the second square bracket portion anionic part. Upon giving name, the PtNH3 portion is named first, being a cation, followed by the anion Pt Cl4 2-. Okay, so that's the very first rule. Cation named at first, followed by the anion. Then rule number 2, while giving name of simple ions, you know that the complex salts may have simple ions, isn't it? Either maybe a simple cation or simple anion. While giving name of that simple ions, they are given their regular names. So also look at the example. So K plus ion is called as potassium, Na plus is called sodium, CO2 plus is called as copper. So these are some example for simple cations. They are given their own names, regular names, isn't it? Similarly, Cl minus ion is called chloride, NO3 minus ion is called nitrate, SO4 2- is called sulfate. So these are some example for simple anions. Even the simple anions also given their regular names. Okay, that is the second rule. Simple ions are given with their regular names. Okay. Then rule number 3, in case of complex ion. You know, generally complex ion consists of central metal and silicon about n times with a charge plus or minus, isn't it? Okay. In case of complex ion, which means either cationic complex or anionic complex, the silicons are named at first. It consists of metal and silicon. While giving the name of complex ion, first we have to give the name of the silicon, followed by central metal ion. Okay, this is the third point we have to consider. Okay, complex ion silicon named first, followed by central metal ion. Okay. Now, you know, we have various types of silicon based on charge. So there are negative silicons, positive silicons, neutral silicons also, isn't it? Generally, the name of negative silicons ends with a suffix O. For example, Cn-. So its common name is cyanide, but in complex salts it is called as cyanido. Cl-, common name chloride. In complex salt or when it acts as a silicon, it is called as chlorido. Okay, so like this. Then the name of positive silicon generally ends with a suffix IUM. So I have given an example. A silicon with formula NH2 single bond NH3 plus, so which is called as hydrazinium ion. Okay, you can see in the name there is a suffix IUM, isn't it? Right. Then so that while giving the name of negative Licon, so that we have to add a suffix O. Chloride, chlorido, fluoride, fluorido, sulfide, sulfido, etc. Positive Licon, IUM suffix. Okay. Then there are some Licons which are given special names. So these are the example for them. H2O is called as aqua. CO Licon is called carbonyl. NH3 amine. AMM. AMINE organic amine. To differentiate from that, we are using AMM. Then NO Licon is called as nitrosyl. Okay, so these are the some Licons which are given special names. They are not called by their regular names. Okay, their common names are not used here. Right. Then there are some Licons, what we call it as ambidentate Licon. What is it? Ambidentate Licon. So what is meant by ambidentate Licon? The Licon which has more than one donor atom. More than one donor atom. A Licon with same molecular formula but differs in the nature of atom, which is bonded with the central metal ion. Okay, so look at this. There is a Licon of formula NCS minus SCN minus, which is called as thiocyanate. When you have NCS minus, the donor atom is nitrogen. Only nitrogen is bonded with central metal ion. But while giving name of that, we have to call that as thiocyanate KN. N is nothing but the donor. Okay. Similarly, with same formula, there is another type of Licon, SCN minus. They are also called as thiocyanate, but here the donor atom is sulfur. Previous one donor atom nitrogen, the second one donor atom is sulfur, so it is called thiocyanate KS. Here the S is the donor atom. Okay, right. So this is the point. In case of ambidentate Licon, while giving the name, we have to mention the donor atom. Okay, which is the one which is directly attached with central metal atom. So other example, CN minus. Cyanido KC. Here donor is carbon atom. NC minus, also called cyanido, but donor nitrogen, so KN. Okay, and one more example, Licon with formula NO2 minus, which is called as nitrito KN, donor nitrogen. In the same formula, there is another Licon ONO minus, which is also called nitrito, but donor oxygen, so KO, nitrito KO. Okay, right. So that the point what we have to remember here, when we have ambidentate Licon in a complex salt, the donor atom has to be specified. Donor atom has to be specified. Okay, right, after its name. Then we are using Greek prefixes. We are using Greek prefixes such as di, tri, tetra, penta, hexa, etc. to represent the number of Licon. Okay, to represent the number of Licon, we are using Greek prefixes. Okay, right. Some case we use alternate prefixes. So alternate prefixes like bis, tris, tetrakis, etc. Bis for 2, tris for 3, tetrakis for 4. Likewise, pentakis for 5 number. Then hexakis for number 6. Okay, so these are alternate prefixes. Some place we use alternate prefixes. Where we use alternate prefix now? The Licon contains Greek prefix. Suppose in the name of the Licon, if we have the ordinary prefix like di, tri, tetra, etc., then in such a case, we have to go for alternate prefixes. Okay. For example, there is a Licon En. There is a Licon short form En, which is nothing but ethane 1,2 diamine. Okay, right. So now look at the name of the Licon. Here there is a term di. There is a term di, isn't it? It's an ordinary Greek prefix. Okay, right. When we have this Licon in a complex, to represent its number, we should not go for Greek prefix. We have to go for alternate prefix. Okay, so suppose if this En Licon is present about 2 times, then this is supposed to be named as bis. Is not named as di. It is named as bis ethane 1,2 diamine. Okay, right. Then whenever we use alternate prefix, the name of the Licon is enclosed in bracket. So after bis, ethane 1,2 diamine is supposed to be enclosed in bracket. While using Greek prefixes, we don't enclose the Licon name. but while using alternate prefix bis, tris, etc., the ligand name must be enclosed. Okay, right. Then we follow alphabetical order. See, in a complex, if there are more than one kind of a ligand, then we are supposed to follow alphabetical order. For example, in a complex, in a single complex, you have ligands like NH3, then H2O, and Cn minus, for example. So this is nothing but amine, isn't it? NH3 ligand is called as amine, H2O ligand aqua, Cn minus ligand is called as cyanido, isn't it? But now while naming the complex, so we have to follow alphabetical order, so that the amine ligand is named at first, which is followed by aqua ligand, then only we have to go for cyanido ligand. Okay, right. That is another rule. We have to follow alphabetical order when there is presence of more than one type of ligand in a complex. Okay, right. Then complex anion. So if a complex salt has anionic complex, that is square bracket portion in the second part, then in such a case the name of the central metal ion should end with a suffix ate, or simply if the square bracket portion is at the second part, the central metal ion name should end with ate. Okay, suppose if the central metal ion present in anionic complex is Cu, which is to be named as cuprate, Ni is called nickelate, Cr is supposed to be named as chromate ion, whether it is ferrous or ferric, ferrate, platinum, platinate, silver is named as argentate. Okay, so this is another important rule in anionic complex. Square bracket portion at the back side, here the metal name should end with a suffix ate. Okay, right. Then the next one, the oxidation state of central metal ion should be mentioned. Oxidation state of central metal ion should be mentioned in Roman number after the name of the central metal ion. Okay, so while giving the name of the central metal ion, the name of central metal ion should follow the oxidation state of central metal ion, which is in Roman number. Okay, right. Suppose if a complex salt is charged, or if you have only ionic complex, either cationic or anionic complex, the name of that complex should end with ion. Okay, right. Suppose if you have a complex like this, metal and ligand with some plus charge, or metal and ligand with Lacanian number, ligand with certain negative charge, then name of these kind of complexes ends with ion. Okay, right. So these are the various rules we have to follow while giving name of the complex compounds. Okay, so let us see one example. There is a complex of formula K4FeCN6. Okay, first let us find out which are cations, anions. Well, here the first portion is cation, K4, isn't it? Our cation is K plus ion, which is given a regular name, potassium, isn't it? Right. Then the second half is anion, FeCN6 with net charge 4 minus. It's a complex anion. This coordination compound contains anionic complex, isn't it? Right. Up now, in the anionic portion, the ligand is Cn minus, which is called as cyanido, and this is an ambidentate ligand. Here the donor atom is carbon, so that the name is given as cyanido Kc. Okay, right. Then how many cyanido ligands are there? 6 ligands. So that there are 6 cyanido ligands, so that we are using a Greek prefix hexra, so that ligands together is called as hexacyanido Kc. Okay, right. While giving the name of complex ion, ligand first followed by the central metal, so that cyanido ligand is there with 6 times, so that is called hexacyanido, being ambidentate Kc. Okay, then we come to the central metal ion. Here the central metal ion is Fe2 plus ion, ferrous ion. It is present in anionic complex, so that the name should end with ate suffix, so it is called as ferrate. And the oxidation state of central metal ion is +2, so its oxidation state is mentioned in Roman number. But now when you combine the names together, you get potassium hexacyanido Kc ferrate 2. So that is the complete name of this complex. Okay, potassium hexacyanide Kc ferrate 2. Okay, so this is how we are supposed to name the coordination compounds according to the IUPAC rules. Okay, thank you. So in the next video I am going to discuss the nomenclature of many compounds. So if you attend that also, you can get a clear idea about the naming of complex compounds. Okay, thank you.